Hey, this is to help you with your homework this weekend over percent composition problems and empirical formulas. For section A and B, you are just basically doing percent composition problems where you take the mass of the compound, the molar mass of the compound, you take the mass of the element that's in the compound, and you're going to divide that by the molar mass of the compound. This is also the molar mass of the element. So the molar mass of the element that's in the compound divided by the molar mass of the compound, and you're going to multiply that times 100 to get your answer in a percentage. And if you'll use 2 decimal places for your answers. So CR203. The molar mass of this compound is 2, and then the mass of the element chromium is 52.00 grams per mole. Plus, there's 3 atoms of oxygen. And when you do the math on that, you get this molar mass of the compound, 152.00 grams per mole. So if I want to find out the percent of chromium that's in that compound, I'm going to take 2 atoms of chromium times its mass, divided by the molar mass of the compound. Then I'm going to multiply that times 100 when I do my division there. And when you do that, you will get that in that compound, chromium 3 oxide, that you get 68. It contains 68.42% chromium. So you're going to do that for oxygen, and you should come out with 31.58% oxygen in that compound. You can double check yourself. The 2 percentages should add back up to 100% if you're rounding correctly. Okay, so that's how you're going to do A, 1 and 2, and B, 3 and 4. On the next problems, on C, you're finding the empirical formula. So the instructions for that, the steps are: you take the percent composition, change that to mass by multiplying times 100 grams, which basically just takes the percent sign and changes it to a G. So it's percent to mass, mass to mole, divide by the smallest mole amount, and multiply till whole. So on the first problem, they're starting out with the mole amounts. So you're starting with divide by small on this one. These two, you're starting at the very beginning, and on this one, they've already given you the mass amount, so then you're just starting with those masses, setting them up in a one-step T-chart. I'm going to work through one of these problems for those of you who are out on Friday when we went over how to do these. So I'm going to start with problem number 6. And problem number 6 says we have a compound that consists of magnesium and nitrogen, and it gives your percentages there. So my first step is change that percentage to G. So I have 72.2 grams of magnesium, and I have 27.8 grams of nitrogen. So what we just did is change that percent sign to a G by multiplying that percentage times a sample size of 100 grams. So that's your first step. The second step says to change the grams to moles. Grams to moles is my second step. So I'm just going to do a one-step T-chart going from grams to moles. So this one, we're going to bring grams of magnesium here. 1 mole of magnesium goes up here. And the atomic mass, or molar mass of magnesium, is 24.31 grams. Nitrogen We do the same thing, take its mass and change it to moles. And this is going to be 14.01 grams for nitrogen. So then this is going to end up being 72.2 grams of magnesium divided by 24.31 grams of magnesium. So the grams cancels out, and you end up with 2.9699. Alright, so that rounds off to this. You need to keep 4 decimal places on these. And when you divide this one, you get 1.984 moles of nitrogen. When you do the division there, you get 27.8 divided by 14.01. You get that mole amount. Now the next to last step on these is to divide by the smallest mole amounts that you have. So looking at these two answers, which one is the smallest value? And that is this one right here. So we divide all of the mole answers that we have by the smallest mole answer. And that gets us 1.497 on this one. And when we divide through by this, of course, that gets us a 1. This decimal point is too far away to either just drop it or to round the 1 up to a 2, because we need to get these to a whole number. So I have to figure out what whole number I can multiply times 0.49 to get rid of that decimal place. And so since that's really close to 5, we're going to multiply times 2. And if I multiply this times 2, I've got to multiply this one times 2, because now when we divide it all the mole amounts by the smallest, we set up a ratio. So what you do to one, what you multiply one of these ratio numbers times, you have to do to the other. So when you multiply 1.497 times 2, you will get 3, and 2 times 1 is 2. And now this number and this number are the subscripts for the elements for the empirical formula. So the empirical formula for this problem is Mg with the 3 and N with a 2. So this is magnesium nitride for your empirical formula for number 6. That was the problem that we were doing on that one. So if you have any trouble with this, go back, watch it again, pause it. You may not have to do this last step, multiply to a whole. If the decimal value is 0.9 or above, you just go ahead and round that off. And if it's let's say below 0.2, you can just drop the decimal place and you have your whole number. The other ones you're going to have to multiply to a whole. So if you have 0.25, you're going to multiply that times 4. If you end up with 0.2 or 0.8 for your decimal value or something very, very close to that, you're going to multiply through by 5. And if it's 0.33 or 0.66 or 0.67, you're going to multiply those times 3 to get rid of the decimal values on those. That again, those numbers are at the very bottom of your notes page that you received on Friday. So again, if you watch this video again and you still don't understand how to do the steps, please don't hesitate to text or give me a call, and I will be more than welcome to help you. So there are the steps again. All right, great. Have a great weekend.